project outlined in the sources follows a sequential data science workflow to predict sales revenue based on advertisement spending. Below is a detailed explanation of each task, including the libraries used, R2 scores, and performance comparisons. Task 1. Importing libraries. The project begins by importing essential Python libraries for data manipulation, statistical analysis, and visualization, pandas and numpy. For data handling and numerical operations, Seaborn and Matplotlib. For creating visualizations and setting plot styles like ggplot, SIPI. Used for statistical analysis, specifically for checking data skewness. Task 2. Data loading. The dataset, advertising.csv, is loaded into a data frame. It contains advertisement spend across 3 channels, TV, radio, and newspaper, and the resulting sales revenue. The data is inspected using df.info to ensure there are no null values. Task 3. Exploratory data analysis, EDA. A pair plot is generated using Seaborn to visualize the relationship between each advertisement feature and the sales response. This helps in identifying linear trends and understanding how different features relate to one another before modeling. Task 4. Multiple linear regression, estimating coefficients using scikit-learn's linear regression. A model is built to estimate the impact of each advertising channel on sales. Intercept, 2.938. Coefficients. TV, 0.04576. Radio, 0.18853. And newspaper, minus 0.00103. This indicates that radio spending has the highest individual impact per unit of spend. Correlation heat map. A heat map is used to visualize the correlation between variables, showing a strong positive correlation between TV/radio spend and sales. Task 5. Feature selection and comparison. The project compares 2 models to determine if all features are necessary. Model 1. TV and radio achieved an R2 score of 0.89719. Model 2. TV, radio, and newspaper achieved an R2 score of 0.89721. Comparison. Addition of the newspaper feature barely increased the R2 score, suggesting it does not contribute significantly to predicting sales. Task 6. Model evaluation using train/test dataset to evaluate how the model performs on unseen data. The dataset is split using train_test_split. Focusing on TV and radio features, RMSE, root mean squared error 1.3879, R2 score, 0.9176. Task 7. Model diagnostics. The yellow brick library is introduced here to provide visual diagnostics. A prediction error plot is used to compare predicted values against actual values, showing an R2 of 0.918 and helping to identify where the model deviates from the identity line. Task 8. Interaction effect, synergy. The final task explores synergy by creating a new interaction feature, TV*radio. The theory, advertising on TV and radio simultaneously might have a greater impact than the sum of their individual effects. Performance. This model showed a massive improvement, reaching an R2 score of 0.9789 and reducing the RMSE to 0.711. Final comparison. This interaction model is the most accurate, as visualized in the final prediction error plot where the data points align much more closely with the identity line.